So I'm giving you this graph. I'm telling you the vertex is at negative 3, 5, negative 3, negative 5. I want you to write the equation of that parabola. Okay, which form is going to be easier, standard or vertex? Okay, to do something like this, you have to do it in vertex. Standard just would not work well. And so if you know the vertex is at negative 3, negative 5, which numbers can you fill in here? So if it went left 3, what was in the parentheses? It was the opposite sign, so that would have been x plus 3. And it went down 5, and that stays the same, so it would be minus 5. Now the tricky part is figuring out A. If they've graphed it for you, you can pick it up off the graph fairly easily. Because if you think about our good old 1, 2, 3, 1, 4, 9, you should have a point. I use the 1, 1 point. It's the easiest. Does this graph go over 1, up 1? It goes over 1, up how many? It goes over 1, up 2. So therefore, I multiplied that y-coordinate by what? 2. So therefore, it's 2. So if they actually give you the graph that you can see, you just go over 1 and count how many boxes did I go up or down, and that's what it was. The other way they can give it to you is like this, where they give you the vertex and they tell you another point on the curve, but they didn't graph it for you. You can get graph paper out and try to graph it, but the problem is it's pretty hard to draw the perfect parabola and see exactly where it's going through the corners of your boxes. That's pretty difficult, so we kind of have to go another route. You still start it the same way. You can always fill in the vertex. Then we'll worry about A in a minute. A is going to be the sticking point. Because if that's a positive 4, then yes, it was x minus 4. And if that's a minus 2, it stays minus 2. Okay, the question is, how do I find A? Okay, there's 2 ways you can do it. We can figure it from the 1, 1, 2, 4, 3, 9 thing again, or we can figure it with algebra. Because one of you started to say it. Since they gave you a point, you can fill this 610 in for x and y and just solve for A. That's the algebraic way to do it. Or we can reason it out from the graph. Got a preference? You want to do it both ways? What? It's about the same. I'll just show you both ways. If you do it from the perspective of the t-table, you have to ask yourself, look at the x-coordinates. My vertex is at 4. My y-coordinate was at 6. Yeah, I moved over how much then? I mean, my next x-coordinate. That's a difference of 2. So that means I went over 2, which means I should have gone up 4. But I went from negative 2 to positive 10. How far was that? From negative 2 below the axis to positive 10? That's 12 units. Didn't that go between those two? So instead of going up 4, I went up 12, which meant this thing got times by 3. And so you know you would have a 3 there. So you can reason it out that way and know there's a 3 there. Or you can, if you don't like trying to do that, just fill the point in. You're trying to solve for A. You know you have an x-coordinate of 6. And you have a y-coordinate of 10. Just do the algebra and solve for A. That's whichever fits your brain better. The key thing is order of operations again. What do I get out of this quantity squared? 6 minus 4 would be 2. Squared would be 4. That's 4 times A. So you have 4A minus 2 equals 10. Add the 2 would be 12. And divide by 4 would be 3. And either way, then, we got a 3 for A. So your equation would be 3 times x minus 4 squared minus 2. So You can fill it in and solve it with algebra, or you can reason it out from the graph and look at how much you moved over versus how much you moved up. Whichever way is more logically fitting your brain. Okay, last thing. Remember I told you we'd have lots of real-world applications? Virtually every time you do from now to the end of the chapter. Every day there's some real-world, showing you real-world examples of this. Quadratics are used in tons and tons of areas of the real world. Tons. Okay, this is a classic one here. So suppose you run a clothing store. You're currently selling 40 pairs of jeans a day, which to me seems like a lot of jeans, at 30 bucks a piece. And you've been doing some research, talking to your customers, and you figure that every time you up the price 3 bucks, you're going to sell 2 less pairs of jeans. So the question is, what's that right price to charge so that you make the most money you can? Because, I mean, if you up the price, you're going to make more money there, but you're going to sell less. So where's that balancing number? If we up the price to $33, how many jeans are we going to sell? 38. If I up the price to $36, I'm going to lose 2 more pairs, so I'm going to be down to only selling 36 pairs. So you could sit here and crunch all those, but the answer might be maybe I should up the price to $34.50 or $35. It doesn't have to be on these even increments. So we're trying to find out where is that price that's going to maximize our income. We want to make the most money. Big key word, maximize. We'll come back to that in a second. Okay. Right now, if you're selling 40 pairs for 30 bucks, how much money are you making? How do you figure out how much you're making? 40 times 30. Aren't you taking the number you sold times the price? Okay, so that's the basic formula. That's what you're doing here. Common sense. You guys do it all the time. You go in a store, you figure that out. You don't even think about it. Okay, what we have to do is we have to turn this into an equation. So in our instance, we're currently selling 40. What's going to happen when we up the price? Are we going to sell more or sell less? We are going to sell less. How many less? 2 for every time we change the price, for every $3 change in the price. So how am I going to write that? 2x, where this is the weird part. X is the number of price increases you're going to do. I wrote that wrong. Number of $3 price increases. So we're talking about how many times am I going to make this price change. Okay, so that's the number I'm going to sell. What's the price I'm currently charging? Currently charging 30 bucks. What am I doing to it? I'm adding $3 for every price gain, so 3 times x. Okay, well, that's nice, but that's not quadratic. You have to FOIL it, because if you FOIL it, won't it become quadratic? Yeah. So if we FOIL it, because I'm running out of time here, I'm going to FOIL this relatively quickly. 120x minus 60x minus 6x squared. You're always going to be able to add up the middle terms. So that's actually plus 60x minus 6x squared. Okay, my question is, what do you want to find to answer this? Okay, so I got a quadratic. It's a parabola. What's that have to do with my ability to answer this question? I underlined it. Maximize. This is a parabola. Is this a parabola going up or a parabola going down? Look at your x squared term, which is hidden in the back. It's negative. This is a parabola going down. So therefore, where's the maximum going to be? At the top, which we call the vertex. Anytime it says maximize or minimize, it means find the vertex. So all you have to do is find the vertex, and it'll tell you what you should do. Now, be careful here. If you try to do negative b over 2a, what's B and what's A. The B is in the middle, it's still okay, but remember A's back here since it was negative, so it's 2 times negative 6.
Winners of the Teen Read Week gift certificate are Kenneth Stallmoller and Gabriella Sidwell. Please go to the library and see Mrs. Silverich.
Okay, now, is this saying raise the price $5? It's saying raise it 5 times. So, how many times? How many? Yeah, that would be $15. So this is saying 5 times $3, you're raising it $15, added on to the $30. So you actually, in the end, the answer to the question is, I should charge $45 for my jeans, and I will make the most money possible. Well, who knows? These didn't say these were designer jeans like you all want to wear. These might be your standard farmer Levi's or something. But, okay, any time in any problem, if they say maximize or minimize, it means you find the vertex. Every time. Maximize or minimize, find the vertex. Have a